Okay, so, welcome all 10 of you. Can you put phones away and your Chromebooks away and get out a notebook? And can you do the math steps for this, like algebra questions? And the point is to map that onto the things you need to do with matrices. Yes,
Solving with X-Y equations was on the delta math a few years ago,
yes.
and we're just learning it now.
Well, we've been doing them and we're continuing to work with them. So there's 3 days that say solving matrix equations as homework. Tonight's homework is on delta math. I will be checking it and putting it into the grade book tomorrow, all right? Oh. I heard you were coming. Thing. Yeah. Okay, so what's the process? I want to know the process more than just the answer. So what is your process?
So subtract x on both sides. -180. And then multiply that by 3 times.
And then multiply by the reciprocal.
Which is what, just
The reciprocal is that fraction turned upside down.
but how would you multiply 3 over 2?
Okay,
You just do common denominator
okay. On this side, do you agree that 3 over 2 multiplied by 2 over 3 is 1? Because this 2 divided by that 2, this 3 divided by that 3. All right, on this side, I'm going to make numbers smaller because even though I'm a math teacher, I don't do 3 times 28 well. 28 divided by 2, though, that's -14. -14 times 3, I don't do that one well either, but I know 3 times 2 is 6, and 28 is 2 times, or 14 is 2 times 7, so 6 times 7 is 42, and I'm going to put a negative on. Okay. But with just straight up algebra numbers, subtract or add the stuff away, as Aaron said, to get dump with x equals just a number. And then he said to get rid of the stuff that is still attached to the x, we need to undo multiply by divide. Perfect, yes. So, matrices. As a matrix, this is similar. Aaron's first step with the numbers was to subtract the 10. What do we do with the matrices? Subtract the box of numbers, subtract the matrix, right? Okay. So I'm going to subtract that. And I get 3a equals, Israel, what do I get when I do this box of numbers minus that box of numbers?
and 17.
Okay. And Crystal, that's not A. I want A, but I have 3 up, and how do I get just A?
Divide by 3.
How do I divide a box of numbers by 3?
Do we just make all the numbers, like a box of numbers that's, a third, yeah.
So when it's just a scalar is just a number, I can do this.
None of them simplified further.
No, none of them got pretty. So on some of the delta math, it might be -8/3. Don't do a decimal, it might get more angry. So leave it as the fraction, -8/3. Cool. All right. So our goal is to use matrices to solve systems of equations. So okay, there are the answers that were on the previous page. So, last class, this is where we got to, and I think we should probably do this again. So if you multiply by 3, how do you undo multiply by 3? You divide by 3. When we multiply by a box of numbers, do we need to practice one of those first? No? Okay. Well, to undo multiplying by a box of numbers, I need to multiply by its inverse. And part of the last delta math, which if you didn't do it, please do it, was to just find the inverse matrix. Step 1 of finding the inverse matrix is we need to know the determinant. Evan, do you remember how to find the determinant of a 2x2 matrix? Yeah.
It was, they were like,
Well, with
it was
these
gonna be
numbers-
6 times 4
6 times 4
minus -2 times 3.
minus -2 times 3. So the determinant is 30. Okay. So, Nana, looking at this pattern, the inverse of B is going to be 1 over that determinant that Evan just found for us. And then we need to do swaps and stuff. So using these numbers, how do I change it up like it says to do here?
So 4, on the right side, you got 3, -3. Boom, 2, and 4, and 6.
Okay, so I have to write it, I have to do it in this form. Diagonally trade those two. And then the other two, leave them where they were, but change the signs. That's my inverse. Okay. And to prove that it's an inverse, if I multiply this guy by this inverse, B inverse times B. I should get the identity matrix out. Margot, what dimensions, what size is that identity matrix going to be?
It would still be 2x2.
It would still be a 2x2. So do you remember what numbers are going to be in it if it's the identity? Can't remember who told us this on the last. Do you remember?
One of the ones are diagonal.
One's down the diagonal, Tommy did this. And he said all the rest of it's going to be filled with zeros. All right, so let's verify that this is going to, like, this should be what comes out. All right, so Jason, I'm going to leave this ugly 1 over 30 out front. But what is that spot going to be?
It should be 24 plus 6, which is 30.
Okay,
And then the top right then would be be 0.
4 times 3, which is 12,
Be 0.
minus 12, which is going to be 0. Okay. Tommy, can you tell us this bottom left? 6 times 2 plus 6 times -2? 0. 0, okay. Samara, the last row at the bottom with this guy. 2 times 3 and 6 times 4?
6 and 24. So 30.
So I get 1/30 times this matrix. Does that become the purple one that is the identity matrix? Yes, so I did correctly find the inverse. Yes,
What if it's like more than?
what if it's 3 by 3 and stuff? Okay. Which is why matrices are useful, because honestly, you guys would have found, you would have solved this equation using easier algebra. But when matrices get big, when you have a complex problem with lots of data, you would set it up in this organization system and then you would do it on a calculator, which is what we're gonna do next week. All right. Thursday, you're gonna have one that, you'll need to take a word problem and set up the system and be able to type it into the calculator or the Desmos matrix calculator and get the solution. We can do one of those now if you want, but I think we need a little more practice. And then you're gonna have a quiz Friday next week without the graphic calculator and without Desmos. You can use the 4 function calculators, but not a fancy thing. And you'll have to be able to do these 2 by 2s by hand. So there are ways to find the determinant of a 3 by 3, 4 by 4, 5 by 5. We don't even teach it in honors because we would use technology to do it. But if you really want to know, I can show you later. All right. So first thing I want you guys to do on these 4 things, not all of them have an inverse first of all, but I want you to find the inverses of those that you can. There were 2 conditions to have an inverse. Anybody remember anything? Yeah.
Does it have to be a 2 by 2?
It has to be square. And 3 by 3, 4 by 4. And in this class, we're gonna top out at a 3 by 3. We're gonna use a calculator for it. So it has to be square. Is there another thing? Just find the inverse we needed. Yeah.
Does it have to have like a determinant that isn't 1? Like it has to have a scalar?
Here's where the determinant goes. What value am I not allowed to divide by?
0.
So the determinant can't be,
0.
so those are the 2 conditions. It's gotta be a square matrix, and the determinant can't be 0. Are all of these square matrices?
No.
No, which one gets thrown out?
C.
That one doesn't work. Okay, yeah.
Getting the determinant, is it A times D minus C times B?
So using the letters makes it, I worry that you've got the letters in the wrong place. So find the determinant, multiply the diagonal down, minus multiply the diagonal up. -1 times -5 is +5. Yes,
So what's the determinant of a matrix that's like 4 by 4?
which is what Israel just asked, and it's very hard to find by hand, and we would let you use a calculator.
Oh my god.
And Desmos does do matrices as well, but you need to look up the Desmos matrix calculator, so it's a different thing. Does A have an inverse?
Yeah.
Yes, because it's square and the determinant was not 0. So Teddy, the determinant, the inverse is 1 over that determinant, and what am I gonna do with the numbers in this box?
I'm not sure.
Okay, well, look here. This was the normal one, and this is how they changed. What do we do?
Positive 5, or
+5,
you flip -5, -3.
what number goes in this top left?
-1.
Okay.
-3.
those guys change spots, so these guys change spots, so you're right, that's a -3. And these guys change sign. So you said +5, that's +1, and what's the number here?
4.
So that's the inverse, and those of you doing the delta math, it doesn't give you the option to leave the determinant on the outside, so you'll have to put it inside. So Fode, what would we be typing into Desmos to say, here's your inverse, you ornery machine. I need to multiply this out to each one.
So you get 3/17,
Mm-hmm.
-5/17, -1/17, -4/17.
Yes. Okay. All right, do the other two. Oh, I tried to take attendance.
Or letter B. It's 0.
Okay, so I hear determinant on this one.
Both of them.
This one is 0, so it does not have a determinant.
Well, it has a determinant, it's just, it doesn't have an inverse.
Correct. Okay, the determinant is 0, therefore it doesn't have an inverse. Correct. Okay, 5 times 6 minus -5 times 6. That is not 0. There is an inverse for D. There's what would that inverse be?
Be 1/60, and then 6/5, -6/5.
And if we had to type it in, Erin, what would we be typing into Desmos, because it doesn't give me the 1/60 outside? Doesn't let me read it there.
6/60. 110. 5/212. 30/110. And then we vote.
Okay. All right, there, buddy? Because it's fun. Do the first step. Crystal, it's just, can you suggest what is our first step to solve? I want to solve for this box, X.
Don't you minus the A -2?
Yeah.
This one.
Okay, so guys, do the first step. Subtract the matrix to the other side. I know, Tony, the bell's never going to ring.
Quite literally, there's no bells in it.
Why is it 6/10 and 5/12?
Because it just simplifies that.
It's simplified that way. 5 divided by 60 is 1/12.
I have a question with this.
Yep.
On the delta math, so instead of like dividing by -1, when it was, and I'm trying to think of an example, but you know when you divide by -1 and get like, it was -x, you wanna get x equals. Like, if it was,
X to the,
if
so
it
I'm,
was the first one minus the x one,
okay,
and then like you move the other one to the other side, so then you have the negative x, and then you divide by -1 to get x. So could you do like, at first I tried to like move the x over and move the other to the other side,
Which should work.
but then I switched them, like I switched all the signs because I was moving it over. Did you not switch the signs, or can you not do it?
It is doable, and I'd have to see what you did to tell you, do you switch the signs or not, because, right here, if I'm subtracting that box, I'm gonna pick the box up, leave the elements alone, and now I'm going to subtract them on this side. 9 minus 8 is 1, -3 minus -2 is -1, 6 minus 6 is 0, 2 minus 1 is 1.
Okay.
Okay? And that's my X matrix times this guy.
Right.
Okay, where we're going with this, I now need to undo this. I can't divide by a box of numbers. I need to multiply by the inverse matrix to make that go away. All right. How did we find the inverse? That was what we've just done, and that's what was on Delta Math, and yeah. Aaron, what do we-
6 times 3 minus 5 times 4.
Okay, so the inverse of this is, it's a process. I've gotta find all the things.
Find the determinant.
Okay, the determinant is 18 minus 20, -2. What do I do with that -2? 1 over the -2, okay. And how do I swaps? How do I move the numbers around? What?
You flip the 6 and the 3, and then you negate the 45.
Trade places with the 6 and the 3 and negate the 4 and the 5. So this is my inverse. Okay, so I need to multiply that onto this side. And here's my concern. I have to multiply it on the left. Okay. If I multiply a 3x2 matrix by a 2x4 matrix, first of all, am I allowed to do that multiply?
Yeah.
Yes, because
It's that
those guys
difference.
match, and the result will be a 3x4. Yeah? What if I did that backwards? Could I multiply a 2x4 to a 3x2?
No.
No, can't do it. So I might be able to do A times B, but I might not be able to do B times A, right? They're not the same. So this A inverse, I multiplied on that side. I need to multiply A inverse from the same direction, okay? It matters. Okay. Which thing should we do first?
Do the A and the inverse of A cancel out?
That, it should become this, and I was gonna just prove that to you. 18 minus 20 is -20, or sorry, -2. -1/2 times -2 is +1. 3 times 5 is +15, -5 times 3 is -15, adds to be 0. The bottom row, -4 times 6, +4 times +6, -24 plus 24 goes to 0. And then -4 times 5 is -20, plus 18, -2 times -1/2 is that +1. So that means this side's just gonna be that matrix X, which is what I was looking for. And this looks scary, so I'm gonna erase it. But that was just to show you all of that stuff is how we divide by a box of numbers. All right. On this side, Tamara, can you tell us how to get the top left box here?
We would multiply by -1/2.
Well, I'm gonna leave the -1/2 on the outside first.
And then you would do, negative, you do 3 times 1 plus -5 times 0.
So it's 3.
Yeah.
Bode, how do I get this one?
3 times -1 and -5 times 1, which is -3 plus -5.
Okay, -3 times positive 3 times -1, and -5 times positive 1, and add it together, and you said that's -8. Perfect. Paris, the bottom left,
Just -4 and 4.
is -4. And then bottom, Clark, how do I get bottom right?
You do -5 times.
This one
Oh,
and this one.
-4 times -1, which is 4, and then 6 times 1, so it's gonna be 10.
Okay. So then our end answer, the X matrix, bringing that -1/2 in, -3/2, +4, +2, -5. That's what the matrix was.
So you wouldn't multiply the -1/2 to 3, -5, -4, and 6 before you multiply.
Okay, I can. Actually, I'm gonna leave that answer there. So if I wanna do that,
It just make things harder.
makes the numbers uglier for you guys to multiply. But we can do that. So if I did those numbers first, if I multiplied by the halves, -3/2 plus 0, -3/2, I still get the same number. -3/2 times -1 is +3/2. And I'm gonna add on 5/2 times 1, is 8/2, which is 4. So we are gonna get the same answer. I just thought it was easier to work with the boxes and then multiply by half. But either one works. Okay, guys, we still have 30 seconds, and please do the Delta homework.